let's begin another broadcast day and such, so forth and whatnot. Yeah, it ends with the same, begins. It's all circular crap. Anyway, that's still working. Yeah, amazing. Anyway, all right. So I think. Let's see, what am I? Yeah, I think we'll just draw for a little bit, and then we'll maybe play a video, and then maybe do something else. We'll see. So Newton's laws, I would state them all differently than Newton states them, and there's probably more to add in terms of ways of saying something important or that matters, I would argue anyway. And so we'll do one thing first. We'll just do this. It's not a law, but it's just this gravity thing, okay, that seems to fool everybody. So there's this idea that you can launch something up against gravity, all right, and then you can drop something in gravity. And the trick is, okay, that if you want to go twice the velocity, you have to drop something from 4 times the height, which doesn't seem at all intuitive. It doesn't, on the face of it, you're just saying, why is there this 4-to-1 relationship when all I'm getting is a 2-to-1 relationship in velocity? So, but it's all kind of understandable when you take it apart, so to speak, and recognize that, okay, so this is one velocity here, and if you use 2 velocities, that's how high you'll end up going, is 4 times the height. So then they have a formula, mgh, which is essentially equal to, the 1/2 mv squared, because, frankly, the height, okay, is doing this not proportional thing. 4-to-1 when it's really 2-to-1, in terms of 2-to-1 for your weight. So if I drop these things, it's only 2-to-1, not 4-to-1. The weight will be only twice as much, even though I drop it 4 times the distance. The velocity is 2-to-1, and the time is just 2-to-1. So this only takes twice the time as this takes. This is 1 unit of time. This is 1 unit of time. So time, weight, and velocity are all saying 2-to-1 is the right relationship. That's what you've got. And so this I clearly would replace with a t, okay, because it's about the time, and then you don't need this, and this equals your momentum. All right, so if you analyze this, as Galileo did 500 years ago, so, I really shouldn't have to be redoing it, but here we are, in spite of what should be. So you can sort of understand it, okay? So we know that it's 9.8 meters per second, okay? So that's what Newton figured out. Now, Galileo didn't know that, but he really didn't need to do all of his experiments. So it's per second, okay? Second, not per second squared, just per second, 9.8 meters per second. That's what you get as a velocity. That's the change in your momentum, okay? Your mass and your velocity changes each second. So in the first second, you only fall, okay? The trick is 5. So let's just say it's 10, just to make it easy. No, let's not. Okay, so all right, so it's 4.9. All right, so that's how you fall, because it takes time for you to accelerate and all that stuff up to 9.8. So after you've fallen almost 5 meters, and it doesn't matter what you are, this pen or me or a brick wall or the Empire State Building, you're all going to fall at the same rate, because gravity is going to give you an amount of energy, okay, relevant to your mass. So gravity affects you based on your mass. So the more mass you have, the more energy it takes to push you, and you get it from gravity. You all get proportional amounts. So the pen gets a tiny bit of energy, I get more, the Empire State Building gets a lot. It collects it. It's like dust, and it's collecting it. All right. So it only drops 4.9 in the first unit of time. And let's just say it's a second because that's how it works out. So in 1 second, all right, something will fall almost 5 meters. That's what it has. That's how long something falls in gravity, in the gravity we're in, the surface of Earth gravity. You fall 5 meters, not 4.9 meters in 1 second. All right, now, so you're going 4.9 meters. You're really going, right? You only went 4.9, but you're actually going 9.8. So you got your full 9.8 worth of energy. All right. And so what happens in the next second? Well, you're already going 9.8, right? So, you know, you're going 9.8 meters. So you're going to, in the second get your 9.8. So we can just draw that as 2 of these 5s, right? 4.9s. So you get 2 of those just from what you've acquired from the first bit of gravity. So the first gravity gave you momentum. You already have that momentum. You're going to keep using it every second. So every second you get this for free because you're already going 9.8. It doesn't take it away. It only adds. So you're already going 9.8. So the second you already get that for free. And now it's going to add another 9.8 because it's a new second. So the first second gave you this. The second is going to give you another that, 4.9. It's going to do the same thing to you, okay, regardless of how fast you're going. You could go 1,000,000 miles an hour, but it's still going to give you that in a second. It's going to give you that 4.9 of distance because it's going to be pushing on you, okay, accelerating you the same way it did the first time. So it's going to give you that 4.9. So the second 9.8, the second only really gives you this. This you already had. So this was already, I've already got it. So I don't know how to draw. You already got it. You already got it. You already got it. Yaget. Okay? So this is Yaget. You already got it. You don't have to re-get it. You already got it. So this is the only bits that you get. The first second gives you this little 5 meters. The second gives you this 5 meters. And this 5 meters you already got. And now, when this happens, now you're going to be going 18. Was it 18 or 19? 19, right? Yeah, 19.6. So you're going to be going 19.6, I think the number is. But anyway, it doesn't really matter. 9.3, I don't know. So now you've got 2 units of, well, it's 16, so it's got to be 19.6. So you already got this. And so the third second, you're going to be getting this for free. 3 units for free. Well, it's really 2 units of gravity, so it's 19.6. So 19.6 is 4 of these. So you get these 4 for free, okay, and then you're going to be adding the 1. You just keep adding the new 1 second, right? So the third second only gives you this. That's all it's giving you is this little bit. That's it right there, that little bit. So each second only gives you this little bit. And this is the yagat. You know, the yagat just keeps getting bigger and bigger and bigger. So Galileo figured it out. It's, 1, 3, 5, 7, 9, 11. It's all odd numbers of yagat. So you just keep getting the extra yagat, and that's all you need, and you just add the new bit to the yagat. So that's the 4-to-1 relationship. So that's why it exists. So you have to understand that, per second, this is all you're adding is energy. So clearly it's only 2 units of energy. It's 9.8 meters per second. It's not per foot. It's per second. Per second I get this energy. So this is the only added energy. I can't make enough arrows over here, right? This. I guess I could change the color. All right. I should add some kind of added features. This little bit here. This is all you get. This little bit. This little bit. That's the energy. The energy is this little piece. The part you already got is the big piece. And that's all you're adding each second is this little piece. Little piece, little piece, little piece, little piece. But that's the real energy you're getting. That's what's being added to your system. And the same thing happens going in reverse. So when you're going the opposite direction up against gravity, the first second you're going really fast. You have the high velocity. So the first second's obviously going to take this long. It's going to take this much time. You're going to go the 3 units of distance in the first second. So in 1 second you do this big giant hunk of distance, and in the last second you do this little tiny, 1 chunk. So the 1 to 4, 1 to 3 relationship exists. You can see that it'll take you 2 seconds, not 4 seconds. You're not fighting 4 seconds worth of gravity, you're only fighting 2 seconds worth of gravity. It's only 2 units of 9.8 meters per second that you're going to be fighting, not 4 units. It's not 9.8 plus 9.8 plus 9.8 plus, no. So the gravity coming down at you is only 2 9.8s. That's all you've got that you're fighting. Alright, it's only 2 units of energy. That's why it takes twice the velocity. Because you need twice the amount of velocity to do those 2 units of time. So you can perfectly understand, it's only 2 units of energy. It can't be more than that. It can't be 4 times. It can't be something else. It's only 2 little units of actual energy being pushed on you. Force pushing you. It's only these 2 little units of pushing. The rest is coasting. And it really shouldn't, frankly, I shouldn't have to explain this to people who, know what a quantum is or something. I mean, people have a little bit of mechanical knowledge should be able to see how that's the way it adds up. It's not that complicated. Alright, to the other arguments. There's some other argument I wanted to do first, but I'm not recalling what it was. So, while I clean the board, I can think which law I wanted to handle first and which rule and all that crap. But so anyway, once you got that part of gravity, we might as well do the linear part since we're talking about gravity and the rules and such. So I'm just saying the 4 part is just an illusion. There's nothing I can say about it. I mean, yes, it looks like it's going 4 times the distance. It looks like that's 4 times the work. But you have to understand, while what it's doing is not 4 times the work, because part of the work is a coast. Part of the work is for free. There's no pushing there's no pushing against, and there's no because it's just time, right? The faster I go across the scale, right, the less I deflect the scale, indicating I'm losing less energy to the ground because I'm pushing into it less. The faster I go per inch, I push less. Per time, I don't. Alright, so that's really, it's frankly, to me, easy to understand. So these experiments are all kind of done in the real world we exist in, which is a friction world. So we don't do an experiment where we create some sort of mechanical system that takes away something's energy. So you could argue that you could put a generator on a wheel, okay, and attempt to extract the energy, okay, into a motor and produce, electricity, and that will be in watts, okay, and a watt is a joule. So there's different ways you can try to pull energy out of something to measure how much energy it has. Now, I would argue the simplest way is just to weigh it, because that's all energy really is I just take a mass and I give it a velocity and a direction and I hit something with it, and it's pretty much going to tell me what its energy is. It's going to push into the object with its energy, and if I do it the right way, that is, I create an inelastic interaction where it sticks, I can hope to get all of its energy in one direction and measure it as just a dent here even. But then I have to be aware that this has a shape, and so I have to make sure it doesn't have a shape that will distract me from the truth again. But the idea is there's ways to collect this stuff called energy. Now Joule, the guy they named the energy after, figured out that he can make a water tank and swirl the water with a paddle, and if he insulates the whole thing and then measures the temperature, he can basically tell you, I can make something cause an action and I can measure it. But he had the same problem of how to capture the energy, how to bang something into something. And so what he did is just he dropped things on ropes in gravity. So he did it, you know, the lamest way you could do it. It wasn't like crashing something into something and then try to collect the energy, because frankly you're not going to get all the energy into your tank. You're going to miss some of it, because some of it's going to go in ways that aren't the way you want the energy to go. You want it to go in the direction you're trying to measure. You don't want it to go in all these other directions that you aren't collecting, because your ruler won't see them. If you have a ruler and you're trying to measure the energy, all you can see is this on the ruler. All you can see is the stuff going this way. You can't see the stuff going that way. All right, so it's the real catch for the experiments is it's hard to design an experiment that doesn't create some scatter losses, and that the losses can be substantial, and so it's really hard to measure the energy if you're only measuring a portion of the energy. All right, so this problem is they do all these experiments in, you know, terrestrial gravity, and there's the same problem. So what you end up with is, if I create this simple experiment where I take a half mass, okay, and I give them both the same energy, the same amount of velocity, momentum. I hit them with the same force, technically. What I'll end up with is this one will have twice the velocity, because I hit it with twice the force. So twice the force, and it ends up rolling 4 times the distance. So it goes all the way down here, where this only goes here. Now, obviously, if you look at this, you're going to say, shit, this has no energy, and this has a ton of energy. I mean, it's a huge, gigantic difference. But it's the same thing as the gravity argument, because gravity is creating the friction. So in a unit of time, right, this will take only 2 seconds. So even though it's 4 units of distance, it's only 2 units of time again. Okay, key thing. And in those 2 units, it's this 9.8 thing happening. So it's only 2 units of energy hitting this, and I mean it's only 1 in this case, because this stops at 1 second. So this only rolls for 1 second. This rolls for 2 seconds. So this one's only in the gravity 1 second. This one's in the gravity 2 seconds. And so you can understand it's the same argument as in the gravity argument. That the high velocity means you're not going to go half the speed to get here. This will be half your speed is here, instead of where it should be here in the middle. Right? So if this was linear, that is, if you're losing the same amount of energy per foot, you would have to run out of half your energy here, not here. So, you know, that's sort of a giveaway of what's going on. You're just coasting through the gravity. It's only 1 unit of gravity for this whole distance. Right? So while this is doing just this in the first second, this does all of this in the first second. So it's only 9.8 spread over all of this distance. 9.8 over this entire distance. And it's 9.8 over this tiny distance. So per foot, this is getting pushed down a lot more than this is getting pushed down in the surface, in the sense that per inch, there's a lot less pressure. So this has a lot less pressure into the ground. This has a lot more, because it's a lot more per square inch. All the energy, the 9.8, has to go in this tiny area, where the 9.8 is spread over this giant area here. And it's not until he gets to 3/4 down the track, that is after the first second. The second second is exactly this. Okay, so that's what it does. It has real heavy pushing, 9.8, a full 9.8 of pressure here. So you only have one 9.8 here, you have one 9.8 here. In the smaller area, obviously the pressure is deeper, which means you're losing more energy. So you lose half your energy in this little spot, you lose the other half in this giant spot. So it can be understood, this isn't 4 times the energy. It's only twice the energy. It's only twice the extraction force, friction, is only affecting you with twice the extraction. So you had twice the velocity, you lost twice the velocity through this process. You know, it's the same momentum. It's the same total energy. It's just in this different form of velocity versus mass, and it matters. If you have the extra velocity, you'll go further. But you don't, the how far you go isn't measuring how much energy you have. It's just measuring, it's just taking advantage of the fact that you can cheat the gravity, essentially. So yeah, on its surface, the simpleton, right? If I was to be Galileo and I could write a simpleton story, I could write a story about the dumb pope, and I could write a story about some other bozo who asked a question, and I could have a conversation between three people, me, Brozo, and some other idiot. I'm just pointing out, like, well, how could you figure this out, right? Maybe I could use Tim. I could use some guy who just isn't, he's just waiting for somebody to show me, right? And Timmy. So I have Brozo, Timmy, okay, and me in a conversation. And I could just explain, how can you not get this? What else do you think is actually happening? Do you think there's something flawed? There's a flaw in this reasoning somewhere? It's 9.8 meters per second. I mean, we all agree, 9.8 meters per second, okay? Not per foot, not per inch, not per some other crap, per second, okay? So the F, okay, is happening in a unit of time. You get a unit of F, okay, in a unit of time. You don't get a unit of F in a unit of distance. All right. Yeah, and it perfectly explains the circumstance. The 4-to-1 is an illusion, okay, so to speak. It's a deception. Only a sucker would fall for it. I can't think of a perfect analogy, but sometimes plastic stuff can be made to look like food, but it's really not food. And you can understand it's made out of plastic, and it just looks like food. So you don't eat the plastic food. Okay, this is plastic food 4-to-1. The real logic says, oh yeah, I perfectly understand. I really only use the same force here. I cut the mass in half. The velocity is now increased, and the velocity allows you to cheat gravity. You can get through a lot of gravity. The faster you're going, the faster you get through the gravity, the faster you go through the rain. So I could do that simple analogy, and I could just say, yeah, I could use the simple analogy. It's raining outside, right? Okay, it's raining or hailing. And the simple truth is if you're going from point A to point B, well, the faster you get to point B, the less of this stuff can fall on you. It's coming down at a rate, the 9.8 meters per second. The faster you go through it, the less drops of rain will actually fall on you. Now, you'll crash into some, inevitably, just running. Okay, the ones that are already here. But the fact is, if you go fast enough, all the ones falling can't get to you. Okay, and so you're able to get through the gravity without much rain hitting you. But if you walk really slowly, okay, if I have a very low velocity and I take a lot of time in the rain, then I'll get soaking wet. Now, do I really have to explain that to you? Are you such imbeciles that you can't understand the simple analogy? I use a paint sprayer. It just sprays little dots of paint that's shooting out of a little nozzle, right? And you're going through the paint sprayer. Do I have to? Do I really have to explain that, the faster you go through the spray, the less paint's going to get on you? So you're really that stupid? That you can't get it? So, yeah, I mean, that's sort of the irony, though, right? Is that basically Galileo trolled the rest of science. He just basically wrote everything as if he was writing a narrative about how do you convince imbeciles of a simple truth, because everybody was a fucking imbecile. So you were all imbeciles back then, and apparently you're still fucking imbeciles, belligerent imbeciles that can't be told anything and nothing can be explained to you. You just do it the hardest way possible. You stick to your fucking traditions, and that's it. All you know is my traditions. My tradition is eating my hot dog, wearing my sponge number 1 finger, and going Yahoo. And that's all you can do. You know better. Okay, that's all you are. You still, in 500 fucking years, you can't walk off the bandwagon and grow up a little bit. No, you gotta paint your face half blue and green or something, and paint fuck you on your belly and whatever. Fuck you people, you're so goddamn stupid. And then you're pretending you're a scientist and you give a fuck about the truth and all this bullshit. No, you're imbeciles. Belligerent, stupid fucks. Clearly. I mean, it's not that fucking complicated. Clearly, mv squared is crap. A big, steaming pile of crap. It doesn't fit with the real world. It doesn't fit with NASA landing on the moon. It doesn't fit. It doesn't work. It's crap. Jeez. All right, so that was just it is ironic. I mean, yeah, I never thought about it, but yes, the whole approach Galileo had to have is like, I'm talking to a world of fucking morons. All right. So this one I've done over and over, but jeez, it just really proves the point, doesn't it? Come on. All right, so here's something with gravity, okay? And gravity, whether you think it's a push or a pull, it doesn't matter. The arrow is going this way. All right, so the things are being pushed in, and they're being pushed in at a rate, okay? And on the surface, it's 9.8 meters per second. So we'll just say that this is 9. We'll just say this is a number. It doesn't really matter. We can say this is 10 out here. Who cares? So the gravity is an average of 10, okay? So you have a distance from this surface, okay? So the distance here is far, the distance here is closer, the distance here is far again. You're going to just do this path next to this gravitational body. So you could just say there's an average here, right? There's 6 here and there's 10 here. There's, let's just say it's 8, okay? So the gravity is 8. Who cares? The average amount per second. So this is just like the paint sprayer. This is just, gravity is really just saying there's little bits of paint flying and it's going to hit you and push you into the earth, okay? So that's what's happening. And you're going to fly through it. Well, obviously it's time dependent. And so the faster I can go through this area of space, the less I'm going to get bent. So if I go, 100 miles an hour, I get bent this much. All right, my trajectory gets distorted, and I end up going that way. All right, and if I go 50 miles an hour, it ends up being like this. And if it's 25 miles an hour, it ends up like being like this. Okay, I crash because I'm in it way too long. All right, it has way too much time to work on me. It pushes, and it crashes me in. All right. I just keep falling into deeper and harder pressure, and the pressure will consume me. I'll just end up crashing, okay? And, this works for a whole solar system. I mean, this is another argument that's just so old. I mean, people think things just fly into a solar system and they just fall into an orbit. Well, they can't do that. If they come from the outside, they have to hit something to slow them down, or they'll never find a path that'll get them into an orbit. They either crash or they leave. Okay, they just get bent and they leave. They have the same energy they came in with. They go to the other surface and they have just enough to pop back out. So if they don't hit something to slow them down, they are not going to get captured. So I'm sure Galileo explained that to somebody. Well, Newton at least. But yeah, so it's not an important. It's not part of the dispute. But I'm just saying these are the little details that people just have lost mindfulness of, and do this bullshit instead. All right. So let's read some of Newton, I guess, and as some sort of context. See, do we have any viewers at all? 2. Yeah, that just isn't. That's not going to do it. But whatever. It's what it is. The video speaks for itself. We don't need the participants, I guess. I have spoken. Yeah, so who else? What else do we need? I mean, really. The participants don't do much except go, what? Huh? What? Or troll, and just keep saying the same thing over and over and over again. All right, so this is one. There's different versions, right, of everything. You can find any translation. You can find somebody who translates it differently. which is not a good thing. Okay, let's see if I can make that a little smaller, I guess. Alright, so now it actually fits, I believe. No, it still doesn't fit. Well, you really have to compress it. Whoops. Alright, maybe that's enough. Maybe. Yeah, so we finally made it. Alright, so the first law is kind of boring. I mean, frankly, nobody should even have to even talk about it. Blah, 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 right? Everybody continues in its state of rest or uniform motion at a right line, so just a straight line, unless it is compelled to change that state by forces impressed upon it. So it doesn't move until it's hit by a force. It doesn't stop moving until it's hit by another force, telling it that force isn't going to work. Okay, now I would argue, okay, that the system does work a little different than people think. All right, something isn't moving and then some counter force hits and this goes backwards. That doesn't happen. Something moves because it got hit by one of these. One of these hits, and then all I have to do is provide, so now it's moving. And all I have to do is provide the counter hit, and what I'm frankly doing is undoing the first hit, so that one reflects, and this one reflects, and this one has nothing now. It doesn't go this way or that way, it just goes back to stop. And then it has to be hit by something to go again. So force actually is something that sticks to something. So it collects the force. The force is collected, and then you have a counter force, and it's not really going to undo anything or stop anything. It's just going to do what you could argue a Newton's cradle is going to do, is that two forces come in and then two forces go out. It's going to leave the middle with nothing. So the thing in the middle is going to be left with nothing. The counter force comes in and it extracts that force, and this force is extracted, and it's just left with this not moving. Alright, so I'd say that was a good law too. That could be in the list of laws, is understanding that it goes from go to stop to go. It doesn't go this way, go that way. That doesn't happen. You have to go through stop before you can go through opposite direction. All right. But otherwise, yes, this is fine. Nothing happens until something happens to something. Okay, so if a happening doesn't happen, nothing happens. So if something doesn't hit something else, nothing happens. So either photons, radiation has to hit it, or it has to be hit by another pin. But until those things happen, nothing happens. You have to have contact for there to be interaction. All right. So the second law, this is the big one. This is the one we've been talking about. All right, the change in motion is proportional to the motive force impressed. So all that's saying is right, that it's momentum, motive force, okay, the compelling, the thing that has motion. So you could say whatever it is, whether it's in the form of radiation, photons, or it's in the form of another body carrying the force. It's got a pen stuck to it. It's moving, but something is pushing it. And then that push ends up being exchanged. You just start exchanging your different levels of movement through your contact. And so if your contact is incomplete, you have an incomplete exchange. If you have a long contact or a substantial contact, then you'll exchange everything. All right, the change in motion is proportional to the motive force impressed, and proportional means for pretty much exactly equal. Okay, so whatever the force is, that will be imposed upon you as a momentum. The force and the momentum are the same thing. Force is momentum, just a fact, and it will affect you, okay, based on how much of you has to be moved. So big masses take a lot of force to move, small masses take a little force to move. When you're sitting in the 9.8 meters per second, the 10-ton weight collects a ton of energy, a ton of paint, and the feather collects very little because it has very few little atoms to collect it, to stick to. So it collects very little of the paint, and so it needs very little to move. And that's why they move at the same rate, is because they're collecting the energy based on their mass. All right, and is made in the direction of the right line. So there's no right line if it's not moving, but blah blah, in which the force is impressed. So the force tells you which way you're going to go, but obviously you don't go the same way as the force. If you already have movement this way, it'll add a motion this way. So now you'll be going this way and you'll be going that way, which means you're going to end up looking like you're going that way, but you're really doing this and this. So that's the complication of the second law, is that you have to read the rest of what Newton says to really get the idea that you're really doing this and this. But anyway, that it is dimensional. I guess he could say that you can have, for example, 3 unique motions in the 3 perpendicular dimensions. So you could be going a little bit this way, and you could be going a little bit this way, and you could be going a little bit this way. And in those 3 dimensions you have a component of motion, and all 3 of them are doing the same thing individually, but the outcome is that you have a motion in space that looks like this, but it's really made out of those 3 elements. It really is made out of dimensional motion. All right. So this one little simple statement doesn't really say it all, right? The change in motion is proportional to the motive force impressed. Again, the force equals the effect. The effect is going to be whatever the what comes in goes out. Okay, so whatever the force impressed is, it will impress upon you a clear and proportional motion. All right. And is made in the direction and right line in which the force is impressed. So you go where the force tells you to go. So the forces affect something, and the forces decide where it ends up. The matter is a slave to forces. It's a slave to what has stuck to it and is moving it in a direction. And the trick is that it can move it in 3 distinctly different dimensions. 3 distinctly different physical dimensions. All right. If any force generates n motion, so an amount of motion. So if a force generates an amount of motion, okay, a double force will generate a double motion. So it doesn't matter what the object is, a light pen or a 10-ton weight. If I've caused it to move with a certain amount of force, if I double that force, it will double its motion. So clearly Newton is drawing a clear statement. He's making a clear statement. F equals momentum. It will change your velocity. We're not fucking with anything's mass. So we know if we're going to change its motion, we're changing its motion not because we changed its mass and made it twice as light. We're changing its motion because we increased its velocity. So he's making a clear point that if you double the force, you double the velocity. You're not changing the mass. The only thing you've got left is the velocity. So you've obviously doubled the velocity. Twice the force, twice the speed. I could say that clearer, but that's exactly what he's saying. Only an imbecile could see that's not exactly what he's saying. So let me say it again. If any force generates an amount of motion, n, a double force will generate double the motion. A triple force will triple the motion. Obviously, the motion is the velocity. So he's clearly saying twice the force, twice the velocity. 3 times the force, 3 times the velocity. Motion is velocity. I really shouldn't have to say that, right? You agree, I think, that even though it's 300 years ago, that the word motion was a velocity. Okay? You're not going to play some game that it's, oh no, it's technically a left-handed acceleration. Or play some other game. It's clearly motion. I know Newton knew what motion was, and he knew motion comes in different varieties. Slow motion, fast motion. Okay, it's a velocity. All right. Whether that force be impressed altogether at once. Okay, so that's pretty simple, right? Whether it's a quick happening, an event that just, boom, it happened. Over, done, completed in a millisecond. Or gradually and successively. So I slowly but surely push a spring down. You know, I can do something fast, or I can do something slowly. And all that matters is that. What's the scale read? All right. All right, all together at once or gradually and successively. So you can add speed, little increments of push. You can push, with your finger. Somebody could be on a swing and you could push them with your finger. Give them a little tiny bit of extra energy each time they go forward. You add a little forward motion. Or you can push them hard. Okay, and this motion, okay, being always directed in the same way with the generating force, so that's when you're pushing in the same direction as something is going to go, okay, is additive, is what he's basically saying. All right, if the body is moved before is added, so if the direction is the same as the direction you're adding, then obviously you're just adding. Are subtracted from the former motion. So you can sort of understand if you push in the opposite direction, you'll be taking the motion away. All right, I push in the opposite direction, then the thing that's attached, the energy that's attached, gone. I detach part of that energy. Okay. Former motion, subtracted from the former motion according as they directly compare with and are directly contrary to each other. So if it's a deep center of mass contact, like the Newton's cradle, everything changes. This stops, this goes. This was moving, this gives all the motion to this moves, this doesn't. It's a complete exchange. Okay. But if they don't have a direct contact, okay, so it says from former motion according as they directly compare with or are directly contrary to each other, are obliquely joined. Okay, so now we're talking about if they're perpendicular, when they are oblique, so so as to produce a new motion compound from the determination of both. So that's the part where I was saying you can have motion in this direction. Okay, I got somebody stuck to me and I'm going this way, and now something comes this way, okay, and hits me at some other tangential angle, and now it gives me that. So I have this, and then I add the portion that this would be, or I subtract the portion that this would be, and I'm really just saying how much of it's going this way and how much of it's going that way. I'm just comparing the two dimensions, and I'll come up with a final answer that'll say how fast am I going this way versus how fast am I going that way. So you just add and subtract based on which direction in a single dimension at a time. So I don't know if you have to do the dimensional part to get the point. The point is you're just going to add and subtract, and the parts that have something in common, the parts that are not completely perpendicular, this one's going this way, this one's going this way, so they're completely perpendicular, will have nothing to do with each other. Obviously, if there's some other angle, then they'll have some portion to do with each other, and a portion of it's going to be a reflection. So you're going to lose a portion of the energy, okay, and your direction. All right. So, yeah, I guess we do the third law. It's the one I have, I guess, the most disagreement with the way it's stated. Where the fuck is the mouse? That is interesting. Anyway, it's always something. It's computers. All right, every action, there is always an opposite and equal reaction. So that's the part where I'm saying, no, that's the wrong way to look at it. So if I'm moving, okay, and I hit something that's not moving, and I give it what I had, that's only one action. It's not two actions. I didn't need to be made poor when I gave my money away. When I give my money away, there's no counterforce that makes me poor. Just the act of me giving away what I had is the only action you need. That's the only action. The action is this goes to this. That's the only action. There's no reaction. And the catches and the other circumstances is that if you have an explosion, that there's action in all directions. The action is universal everywhere. And that is what is, obviously there's a left component and a right component. So it looks like there's two components to the explosion, but there's two in all dimensions. There's always, yes, there's something going this way and something going that way because it was an expansion or a contraction. So an expansion and contraction always creates an equal and opposite, a pair. But it's just a pair being created by an explosion. There's no actual countering force. There's no other thing that involves itself and creates a counter force. It's just one action that produces, again, in the case of the exchange, it's producing an illusion that something made me poor. That's an illusion. If I give something away, I don't have it anymore by default. I don't need something to take it away from me. There's no counter force that makes me poor. I am made poorer by giving away what I had. Okay. Every action, there is always an opposed and equal reaction. So there's no opposing reaction. There's just the fact that explosions go in both directions, and if you give away what you have, you don't have it anymore. The mutual actions of two bodies upon each other are always equal. So he's again implying sort of like, okay, so this hits this, and they both go off this way. Let's see, this loses the velocity, this gains velocity, so based on the mass, we'll decide how much motion there is. But it's really not saying what's really happening. Like every time there's a contact, this going this way and this is going this way, and you hit them, all you're really going to say is let's take their mass and their, we already have their motion, and let's just do the math. Which one is got more total energy, and you're just going to do the math, and both of them are going to try to share what they have. And so ideally they both leave, okay, sharing completely. But if they don't have full enough contact, then they're only going to partially share their condition. So this one's only going to give a portion of what it has to this, and this is going to give a portion of what it has to this. And so that's going to look like some sort of equal and opposite, but it's really just this is going to share its color with this. So if this was blue and this was red, you can understand there's all kinds of different purples I could make based on how much of this I gave to this and how much of this gave to this based on how much they weighed coming into the explosion or how they hit each other. It's a little complicated. Okay, so for every equal reaction, are the mutual actions of two bodies upon each other are always equal. It's just kind of saying that they're both going to share what they have at a rate that's going to be dependent on how much mass or velocity they have. So if it's velocity they're sharing, that can happen very quickly. And if it's their mass they're sharing as the portion of their momentum, that is, they have a slow velocity but a very heavy mass, you can understand that's going to be slower to translate. You're going to need more time to translate that motion, to exchange it with something else, because it's not fast enough. And directed to contrary parts. So that's not exactly saying equal and opposite reaction. It's a little more complicated than that. So let's read it since I'm here. Whatever draws or presses another, all right, is as much drawn or pressed by the other. So see, he has to use tricky language here because he's talking about two circumstances. You can hit something, or you can be affected by something because it has a force field around it, like the earth and gravity. So the gravitational field can affect you, but at the same time your gravitational is affecting it. But obviously if yours is insanely weak and it's extremely strong, it's not going to look like an exchange. It's going to look like a domination. All right, if you press a stone with your finger, the finger is also pressed by the stone. So the stone, to me, it's the wrong way to say it because, frankly, it's not really going to happen in space. I mean, that's sort of like a human on Earth kind of thing, where you press on something and it pushes back. Well, it only pushes back because it's stuck to something. If I was in space, I'm going to, the impact is going to be shared, and it's really just going to be dependent on who's got the most momentum. Whoever has the most momentum in terms of the difference between the two things is the one that's going to win. He's going to impress a lot more than the other one's going to impress. All right, if a horse draws a stone tied to a rope, the horse, if I may say so, will be equally drawn backwards towards the stone. So I think it's just the wrong way to think about it, because the horse really won't be. It's just that the horse is expending energy to pull the stone, and the expenditure of the energy can... So that's another thing I did want to draw. Can equal... something it's giving away, and if it gives it away in one direction, it has more in the other direction, you could argue. Okay, and that's sort of that's something I've already done before, so I'll do it again. From the distended rope, by the same endeavor to relax or unbend itself, towards the stone, fro the distended rope, by the same endeavor to relax or unbend itself, will draw the horse as, I don't know, mucus. It does the stone towards the horse. Must as. Okay, so that's a word back then, I guess. Much as. Oh, I didn't know much as was one word. Okay, a horse as much as it does the stone towards the horse, and will obstruct the progress of the one as much as it advances that of the other. So that's sort of very complicated. All right. 4, because the motions are equally changed. Well, that's the part that's important. It's just an exchange, and they're both mixing what they have into a final product. The changes of the velocities made towards contrary parts are inversely proportional to the bodies. So he's just saying to the masses, the bodies. So again, he's just arguing for conservation of momentum. If you increase the velocity, you decrease the mass. If you, blah, 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 blah. The law takes place also in attraction and will be proven in the next... Anyway, so he's basically talking in the context of gravity, which is, his prerogative, because that was what the book was mostly about. But anyway, I shall draw another kind of law of motion, okay, that I would argue imbeciliums, Joe Imbecilium, doesn't get. Okay, so Joe Science, he's really whatever, Science Damascius, okay, Damascius Scientosius, okay, give you some kind of name, propagandist, truthist, fucktardia, because you're not getting anything right. Yeah, you're all really stupid. I mean, this really isn't complicated. I've done this over and over again. The fact that you're not catching on just makes it obvious. Why aren't you catching on? Well, I guess because you're just too goddamn stupid. All right. I did a 4-hour video yesterday, and I think it has 4 likes on it. 4. Yeah, 4. It's pathetic. I mean, that's sort of reflection on you, the audience, okay? Why shouldn't I just have contempt for you and how fucking stupid you are? That I have to keep arguing all this stuff over and over and over again, and you really just can't get it. That, wow, that's insightful, and wow, thank you for showing me the truth instead of, I've been fooled by all this propaganda and bullshit. I didn't get how obvious it all is. Shit. Alright, so I've done this before, but okay, so you have a pressurized tank. So you're in space and you have a pressurized tank full of atoms that are closer to each other than they want to be, and that is, you're going to use this as fuel. Okay, and yes, technically what you can do is you can increase the pressure by burning this stuff so it expands even more. So you can make a little tiny bit of it look really, expand really big, okay, and create even more pressure, all right, by igniting it. But the trick is the pressure is in a vessel, essentially. And the simple argument is it's in the vessel, it has all directions. So some of it's going this way, and some of it's going that way, and some of it's going this way, and it just keeps hitting the walls and bouncing off, and it's just stuck inside this pressurized container. And it's pushing in all directions, and it all ends up being an equal amount of pressure because they all bang into each other, and blah, 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 blah. All right. So all the surfaces are getting hit with the same pressure out, 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 out. And it's all by little bits of little BBs, essentially, little atoms moving in all the directions and pushing and pushing and pushing on the other atoms of the material that you've made this vessel out of. Well, the simple truth is when you want to go somewhere, what are you going to do? You're going to let some of this pressure out. And the fact is that I could put a hose on it, and I could run the hose over here and have an opening here. That's just an extension of the inside of the walls. So, even if I twisted the hose, I'll put a little twist in it. The fact is that's just a reflection, okay? That's just this vessel's walls being extended. And so all of these different directions, the stuff is still moving in all these different directions. And it's not until you decide where you're going to have the hose, that is, what direction the hole is opening to, that will decide what you're releasing. Whether you're releasing energy going this way or whether you're releasing a piece of energy this way just depends on where this hole is, which way it's pointed. I point it this way, I'm going to lose stuff going this way because it's all the same vessel. I point it some other way, I'm going to lose stuff going that way. So the simple argument, just to make it easier to see, just get rid of the hose, because that just makes it think. That makes you think, you're able to change the basic dynamic, and you're really not changing it at all. Where the hell is the hole? Here it is. So you're not changing anything with the hose. It's still just the same vessel, and all you're really doing is deciding where you're going to make a hole in the vessel. And the direction you make the hole, what's going to happen when you make this hole? Well, the stuff going this way is the only stuff that's likely to come out the hole, right? The only thing that's going to go out the hole is stuff going this direction, okay? Anything going this direction has a chance of going out the hole. The stuff going this way certainly isn't going to go out the hole. The stuff going that way isn't going out the hole. The stuff going this way can get out the hole. And so everything's just going to go this way that can get out the hole. There's no, this way can't get out the hole. All these other ways can't get out the hole. It's not until you're actually going this way, and you have to be going this way in this little bit of space. You can't go this way over here. That's not going to do you any good. You can't go this way over here. That's not going to do you any good. You have to go this way right out the hole. So the only thing going out the hole is an arrow going this way. That's all that goes out the hole. Every single thing that goes out the hole is an arrow going that way. Now, yes, you can do angles if the hole doesn't have these little edges to it, but let's not worry about that at this moment. Obviously some stuff going at angles will also get out the hole, but it all has this direction. It all has a component in this direction. Every single bit of stuff you let go is going this direction, and now it's outside of the vessel. So now what's inside the vessel? Well, obviously stuff isn't hitting this place here before, so all of this energy, all this stuff going bang 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 this way isn't hitting this surface anymore. And so obviously all the stuff hitting this surface now is more than what's hitting this surface. This surface is getting hit less than this surface. So obviously now there's going to be a bias in this direction. So before, where the pressure was even, you've now made the pressure uneven because you've let a bunch of this out, okay, and you still have this in. And you don't have a compensating this way. So now you've taken the explosion and essentially biased the explosion. So now the explosion's only going in this direction. all the force, all the banging is happening this way, and less of it's happening this way by the amount of your hole. Okay, there's less energy going this way, so now it just has a bias. So there's no opposite reaction here. There's just your action of letting this go. When you let this go, this becomes disproportionately stronger because it doesn't have anything countering it. All of this counter energy, counter force, the yin, is now much smaller than the yang. And so the yang moves because the yin's not there to stop it. And so this whole vessel goes in this direction because you have let that direction go. And that's all you did. And if you wait long enough, the stuff bounces around in here, and even more stuff keeps going out in this direction. So anything going in that direction that's in this portion of the hole escapes. So you just keep letting this way go, and you keep waiting. This way is still hitting the wall. And as the pressure goes down, though, it's less and less and less and less, and your velocity will not increase because eventually you'll run out of pressure. But that's how you're adding energy, is that you're keeping the stuff going this way and you're letting the stuff going that way go. So that's, I think, the more accurate way to understand how things are propelled. They're not propelled by some counter force. They're propelled by giving away what they have, a portion of it, and now they have an imbalance. They gave away the stuff that was balancing them. Now they're imbalanced. So I think these are all good points being made, and all kind of, like I said, a simpleton should be able to understand it. I mean, Joe Simpleton or Simpleton Rodriguez, whatever your name is, whatever title I can give you, you should be getting it. All right, let's see what's going on here now. Turn that back on, and then we can extend it back to its normal size. And then we'll see what's the rate of participation in the live room. That should be here. 2. Oh, okay, 6. It's a little better, but still insufficient to the purpose. All right. So I guess we could play just to see if we can get anybody into the room that has something reasonable to contribute. We could play a stupid video by one of the stupid physicists who are all full of stupid shit. Alright, the crap you people endorse and think is just so smart, blah, 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 blah. So the Silence Asylum guy, okay, talking to his wife, okay, who I probably have more respect for than I have for him. Both cartoon characters, though, frankly. So anyway, let's see what kind of steaming shit this will be. Well, I do like golf.
This brand new swing trainer is quickly becoming the most popular gift of 2023. It eliminates the hassle of owning multiple training aids. It combines everything you need to hit dead straight flush shots into one.
That's in the sweet spot. Is where things are going to get a little weird.
All right, this is where things are going to get a little weird. Well, whatever. Yeah. Shit. Anyway. So it's described as, what are particles? Do they actually exist? I mean, who wants to do this? I mean, why should anybody give a shit? Who cares what the elemental universe is made out of? I mean, whether it's just some little sparkly thing, it's just this sparkly thing, blue sparkly thing, red sparkly thing. Oh, who cares? We know they all are distinct and they have properties. So the little force bits have some sort of properties. They move the speed of light, and they interact with protons and electrons in this inverse manner. And the protons and electrons look really simple in terms of they have simple properties that they affected by the forces in opposite ways. So I send the same force, and the proton says run away, and the electron says run towards. So there, done. Physical properties. Who cares about analyzing it any further, and besides saying, these things are moving through space, They're sitting in space and they're interacting, okay, based on this little stuff pushing the big stuff around. Hello?
I love it when things are weird. Good to know that nothing we've talked about so far has been weird.
Yeah.
Okay.
Hey crazies, welcome to another episode of Wife Reacts. This is my wife, Awkward M.
Yeah, well, you probably should put that in the title somewhere, but whatever.
Hello.
This video is going to be an
Looks like they've both gotten a little heavy, but whatever.
overview of something we call quantum field theory, or QFT for short. Basically, it's what is the nature of matter? Why did we invent quantum fields? You know, what was the motivation behind it?
And so, no, this is going to be a lie, okay? The motivation doesn't have anything to do with this. We have to figure out what fucking things look like, you know. No, that's not the ambition. The ambition is to understand it, formalize its behavior, its properties, its actions. And it seems perfectly reasonable that it is quantizable. There's all this evidence that things happen in kind of a clumpy manner. And that's the real motivation for the field theory, is just recognizing the fact that it looks like you can take it and make it into little distinct bits of energy, okay, causing distinctly proportional amounts of motion like momentum. Yeah.
That sort of thing. So I guess let's start with what exactly do you know about quantum field theory?
I was afraid you were going to ask me this question. Almost nothing that has to do with quantum particles. Gonna go out on a limb here. Where they come from.
Let's just understand context. She's a chemist, okay? She's not an imbecile. So she's science literate. So yes, her specialty isn't physics, but clearly she has taken plenty of educational courses that you could call physics. Okay, just for context.
Where they go, if I had to guess. But I really don't know.
So we're starting from a pretty basic set of knowledge here, right?
Yes.
What is this?
It's a ball.
It's a ball. So just like anything else.
So she lives in a house with all these drawings, all these diagrams, all this stuff that's, you know, pretty much physics, mechanical. You know, the guy's been making these things for a long time. There's little atoms over here that she probably understands perfectly what that is. She probably knows what compound that is. You know, so this is, you know, this is a little bit of a show.
This ball is made of materials, which are then made of molecules, which are then made of atoms, which are then made of subatomic particles. We can just sort of break this down, right?
Right. Why don't we just say, though, you know what? One of the laws should just be, it's basically just made of electrons and protons. That's what an atom is. The electrons and protons are dominating. All of the other particles only last for a trillionth of a second. All the other crap, the neutrinos, all this other baby talk is all kind of just baby talk, okay? Because none of this shit is in any way doing anything real or material in terms of the idea of the quantized force-motion relationship. So that relationship was understood without any notion of 400 other little wacky particles flying around. You don't need any of them. So the basic idea is that we know the electron and proton are the nature of charge, a substantially real thing, and that charge dipoles basically mimic magnets. So we now have magnetism and electricity. We really don't need anything else. So instead of just saying subatomic particles, why not just say, okay, electrons and protons? Because that's what the fucking thing is really made out of. If you're going to say, I mean, there's no point in, you know, you could say dirt is made out of minerals. Yeah, there's no, you know, you don't really need to say anything more. But anyway.
It's a method we call reductionism.
Ooh.
We reduce it into its fundamental parts. Mm-hmm. Now, if we reduce...
Which is you just didn't do, okay? You just ambiguously defined them as this subatomic particle stuff, like it's complicated when you kind of know, no, it's really simple. Basically, it's electrons and protons, and they have this completely opposite properties. So whatever the condition is, protons will generally do exactly the opposite in the same condition that the electron does.
Everything in the universe into its fundamental or elementary parts.
Okay.
What we get is a set of elementary particles.
Sure.
This is
So he's
all
doing it.
of
He's
the
doing
fundamental.
it. He's doing it. He's doing this standard model mushy bullshit. So everything on this chart will be stuff that lasts for a trillionth of a second. Okay, they only see it in accelerators. It only lasts for a trillionth of a second. It doesn't play any significant role. And the gigantic dominant players are proton and electron. Are they here somewhere? Well, we have to go find them because they're in some category. Oh, well, here's the electron, and let's see, here's the proton. Okay, so these are the only two blocks. These are the blocks that dominate this thing incredibly. I mean, they are the controlling features. They're creating magnetism. They're creating electricity. They're creating everything that we really see happen. They're doing the photon interaction thing. They're doing the work all the time. The electrons especially. The electrons are on the outside of atoms. They are the ones busy all the fucking goddamn time. They're the dominant feature. They are why electricity is about the motion of electrons. It's really not about the motion of protons. God damn it.
Or elementary particles that we are aware of.
Yep.
And it's a pretty small list. Technically, every single one of these has an antiparticle.
Yeah, so there's no point. Yes, technically they all have antiparticles, and there's also the virtual particle category, and they all have tau up, tau down, tau this way, tau that way, quark left, quark right. You know, it's just such a pile of shit. There's 400 of these stupid things.
Most of the things that we experience, we interact with on a daily basis, us, all the objects around us, and so on, with very, very few exceptions, are made of 3 of these particles. The up quark, the down quark, and the electron.
Sure.
That's it.
Yeah.
So this is the pile of crap, right? That they're going to cut the proton into an up quark and a down quark. No, you know, half spin, pull of bullshit, or whatever the fuck it is. 2/3 spin and 1/3 spin. Oh, this is so pathetic. But anyway, so yeah, so at least he's doing that. Okay, so at least he's conceding that most of the action is just basically between electrons and protons. I mean, why does he have to do this quirky thing? There's absolutely no reason to break a proton into quarks. The proton has an equal charge to the electron, okay? It's not a quirky charge. It's an equal charge. The north side of the magnet produces the same force as the south side of the magnet, okay? They don't have a disproportionality. So why are you pretending that there's some sort of weird thing over here we're going to call quirkiness, and we're going to have it affecting an electron when we know it's protons and electrons?
And those things tend to interact with each other via photons. Those are sort of the 4 elementary particles that we ever interact with.
Okay, so he's calling a photon an elementary particle when the photon, I think, clearly is understood through Einstein even, okay, that it's made of quanta. The photon is made of quanta. It's not a quanta, it's made of quanta. All right, so, and quanta at a frequency. So it's a collection, a pattern that flies through space and hits a surface. Bang, 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 or bang, 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 bang. And it hits the surface in a certain way. And if it hits the surface in a certain way, it will duplicate the effect of electricity. That is, it will cause in a string of atoms the same sort of cycling or pushing of electrons. That's what it's doing. It's not affecting a single electron. It's not affecting a single atom. It's just ridiculous to think a photon, okay, travel a mile-long wavelength photon is hitting one single electron and affecting it. Very low probability.
Light, as we saw from the particle chart, is made of photons, these particles.
Yes.
What other way do we...
So again, they're not particles and they're not waves. They're a pattern made out of quanta, smaller particles, bits of energy would be the right way to describe it.
Model photons as? What other way do we model light as, I should say? And if you go all the way back to, we model it as waves, right? So an electromagnetic wave is a disturbance in something we call the electromagnetic field. And
so just more made up crap, a magical field, no explanation for where it comes from. Everything has a field, electron has a field, proton has a field, quark has a field, everything has a field, everything has an antiparticle, everything has a field, blah, 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 blah. It's all mush, it is non-mechanical, it's all just so conveniently made up. It's not some kind of field perturbation. It's a goddamn real thing, a real pattern. Yes, now you want to put the real pattern and say all of the density of energy in the universe has these compressions and refractions. Yeah, no problem. But this field crap is the wrong way to use field. The idea that the energy is a field and it has patterns in it is perfectly sensible. But this idea of a field, of a force field, and there's, whatever this is in the force field, that's crap.
that looks something like this.
Yes, I am familiar with this animation.
Right, so
an oldie but a goodie.
An oldie but a goodie. This is one of my faves. In this animation, you've essentially got all these points across space. And each point has a value attached to it, some kind of quantity, in this case, vectors. But there's a...
So this doesn't explain lasers, it doesn't explain diffraction, it doesn't explain how the, again, you've used this model, you're not going to get the right answers for the double slit and all this other stuff. This isn't going to work. All right, this wavy field crap.
A quantity attached.
The universe isn't, a bunch of checkerboard. Okay, and then you just put an X or an O on the checkerboard. That's not the universe.
That's to every point in space, and that's what we refer to as a field. That's what a field is.
Sure.
What we did back in the late 1800s is we modeled light as a disturbance in that field. We do this with lots of things. It's not just with electromagnetism. We can do it with the pressure in a water tank, right? We can assign a pressure value to every single point inside the tank.
We can do it with temperature.
We can do it with temperature, absolutely. When we set up these values...
Yeah, well, all you can do is say at any one moment it all ends up being an average, but at any one moment there's all these differentials. So what? There's all kinds of gradients, you could even argue. So yeah, that's all understandable, but you don't have to create a checkerboard to understand it's just a density issue. And so all you're saying is there's places where there's more density and places where there's less density, and all of that motion is in motion. All of this is in motion. Every second things change because everything's moving in all kinds of randomized ways. Not truly random, just randomized from perception. We can't see the fact that there's definite everything has a prehistory, and there's a reason that everything happens. But all the causes and all the effects are just that, causes and effects.
As a field, it opens up an entire division of mathematics that we can use on it.
Yay! It's what I've always wanted.
Right, it's a really big deal. We can calculate things like divergences and curls and gradients. And so if we can set up a scenario as a field, it's very useful.
So let's just understand. They say they can calculate, but the fact is nobody checks their calculations. So they're calculating it takes 4 times the fuel to go twice as fast. Calculation is garbage. It's nonsense. They calculate that the young double slit experiment produces two photons. Single photon goes through both slits and then superimposes and then entangles and then lands on a surface. When no, there's a rational explanation that says no. Photons are basically, it's a surface experiment. The 2 slit is basically the 2 surface experiment. The double slit is the 4 surface experiment. And it can be understood that all the action just happens on the surfaces, and all you're really doing is changing the phase of photons. And there's a 50-50 chance that on the other wall they're going to be either in phase or out of phase. And so you can break it down to something simple. But if you use their math, if you do their math, you won't get the right answer. You won't get the right answer to the double slit pattern. So nobody tests their math. They just say we can get the right answer. No, you get an answer right? I don't think it's anywhere close to right? They calculate the fuel, the octane of the fuel in a rocket engine. Every calculation at every point in space becomes a different calculation. You know, they'll tell you the fuel has a different octane. I mean, it's just garbage physics. That isn't right. So they keep talking, we have this, and we've done this, and we've done that, when they haven't done any of this stuff.
Very useful tool. Doesn't mean that the field is something that exists. It's just a collection of numbers.
Okay.
But it's a very powerful tool.
Sure.
To somebody who doesn't care whether the answers are right or wrong. So it's very powerful. MGH is very powerful if you don't care whether you get the right answer or not. I mean, if the right answer doesn't matter, then yeah, it's very powerful. We got an answer. As long as it doesn't have to be right, then it's great. It's fantastic math. We don't have to worry about the answer. We just have to do our math. It comes up with an answer. Isn't that all we need? We just need an answer. We don't need the right answer. No one's life depends on it. What do they do when somebody's life depends on it? Oh, that's right. Then they do what NASA does, and they go back to, momentum.
The particle concept of a photon rolled around in like the early 1900s. We started to think that, maybe everything is a particle, and it only looks like it's a disturbance.
It just doesn't make any sense, right? You can't have a mile-long particle or a 10-mile-long particle. It's just too stupid, too silly. Obviously, this is events. It's events at a sequence. There's not a particle that's a mile long. There's a mile of distance between two particles. That's the sensible way to understand what a wavelength is. The wavelength is the distance between the action, between the bits of force.
In a field. As we leaned into the particle model, we started to run into problems, right? We started to run into...
They don't have any particles. They don't have a particle model. The simple particle model is force comes in quantized little particle bits, and there's two kinds of particles it interacts with, electrons and protons. There. That's the particle model. That's the only particles they should be talking about. There aren't any other particles. Those are the only particles that exist. Little particles going the speed of light that hit electrons and protons. Period. End of the particle model.
To not being able to incorporate relativity and having to put patches on to explain the hydrogen atom. And people started to ask the question, what if particles aren't how matter works? What if particles are the illusion?
And they're actually waves.
And they're actually...
Disturbances?
Jellyfish. They're fucking jellyfish. Everything's a little jellyfish. The universe is made out of little jellyfish creating disturbances in the field of ocean. Blah, 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 blah. It's just a fucking baby talk fairy tale crapola. The origin of motion has to be understood. There is something moving the speed of light that interacts with shit and causes it to move. This isn't that complicated. The matter is not moving the field. The field, okay, the action in the BBs that are hitting us are causing us to move. The big things are being pushed by the little things moving the speed of light. It isn't the other way around.
We say waves, but waves is kind of, it can be misleading if you're not familiar with the concept already.
Do we say waves like we say spin?
No, it's not that bad.
Okay.
But if you want to call any disturbance in some medium a wave, sure, but I think it might give someone who isn't necessarily familiar with physics the wrong impression.
Yeah, so he's basically saying, well, you can call an arrow going to a target, and you can call that a wave, an arrow wave. But, yeah, that would be ridiculous, because actually the physics really points to the fact that it is a bunch of arrows. And yes, I could shoot an arrow in the direction, every single direction, right, with my super bow. Okay, I could just pull a bunch of bows in all directions and then release them all at the same time, and all the arrows would go out at the same time. Zoom. And I could say, well, look at this distance and this distance and this distance. And this. Look at that. I could draw a line between all the ends of my fingers, and the arrows are moving through time. And I could draw an arrow. Look at that. I could draw a line, and I could draw another line. I could draw another line. And I could pretend that's a wave. But no, it's a bunch of individual fucking arrows. Duh. Oh, shit.
Okay.
See, because, okay. This is a good question. This is a great question. When you hear the word wave, you probably think of, like a full wave, maybe on the surface of some water or something. A wave on a string, maybe. But
why don't you just make the distinction between mediums that carry waves? That is because each fucking molecule is stuck to another molecule. They're glued together, okay? So I have a glued molecule and a glued molecule, they're all stuck to each other. And so if I fuck with one of them, they all have to move. I can't move just one because they're chained to each other like a chain gang of prisoners, right? So there's a chain gang of prisoners, and, I decide to move one of the prisoners. Well, I have to move all of the fucking prisoners. All right, so those waves are a kind of obvious defect in the sense that I can put energy in any discrete way, and I'm going to get a blended effect out. Okay, they're forced to be blended. I have to drag all of the atoms. Okay, and then the difference between the arrow example I gave, where, there's nothing tying the arrows together, but they will create a pattern in space that looks progressive and looks like waves if you analyze it with wave glasses on. If you're looking for a wave pattern, you can make it look like a wave pattern. But it's a bunch of discrete stuff moving in discrete directions. So the water wave is still individual stuff moving. But the fact is every time it moves more than one atom. So every atom isn't it's just an individual atom moving, but it's dragging a lot of other atoms with it. And that's the only reason why it looks like a wave. It's because it's being forced to be a wave.
In physics, we tend to call any disturbance in some substance or medium or whatever a wave. So even if it's like boom, and
say in the atmosphere, boom, okay, sound, okay, it's being forced to move as a wave because the frickin' air is being compressed. It doesn't stick to each other, but it's being forced into closer contact with each other. It's pushing. The atoms are being forced to be close enough to each other that they can feel each other's electrons. So you can't move one of the atoms without vibrating the other atoms, without moving them. So they're being forced to be glued together. So it's not really, it's not glue, but it's the same idea as the water. The water's doing it because the molecules want to be attracted to each other. The air's doing it because it's being forced by gravity to smash the atoms closer to each other than they want to be. But the same effect is that you can't affect just one atom. You can't hit one atom and have one atom individually move without it, unfortunately, moving into somebody else's space.
It's a pulse that's traveling along a string. That's still considered a wave. It's still described by the same mathematics.
I'm comfortable with that. I think that's okay.
It's still real.
Right.
And so you gotta kind of be a little more vague.
Just because it's not repeating doesn't mean that a wave does not exist.
Right. It's still the same.
Okay.
It's still the same phenomenon, even if it's one.
Right.
It's not a phenomenon. That's the whole point, though. It's an emergent function. It's something that happens because of something that's happening in the elemental condition. So it's really an important distinction that as the arrows move out, there is only one line that's actual arrows. The rest of these are just memories of arrows where they were. So that anything that makes it look like a wave pattern doesn't mean anything because there's only one point to each of the arrows. And it's that point that's actually going to hit something.
I'm going to stop beating around the bush, and we're going to talk about exactly what a quantum field is.
Yes, let's.
Okay. We already saw the electromagnetic field where there was this, vector or arrow attached to every point in space. What if particles are the illusion and matter behaves as disturbances in fields instead?
Okay.
Rather than some value of some measurement being attached to every point in space, it was essentially existence attached to every point in space.
Existence.
Oh, fuck that. Whatever that is, existence is stuck in space. I mean, just too silly, right? I mean, that's just too fucking goddamn silly. I mean, this whole idea, it started with Leibniz, too. I mean, Leibniz was in on this whole, the universe is an illusion. It's all fake, okay? It's all just God's, there's either God or there's soul. And that's all there is in the universe, right? There's no matter. There's no material functions. There's nothing. There's just matter and there's just God and souls. I mean, please.
Of what we would perceive as a particle.
Any particle?
Any elementary particle.
Yes, okay.
Yeah.
It's not like only electrons are found in the electron field and only
Up quarks?
up quarks, yes, are found in the up quark field.
That's how it is.
That is how it is.
Yes,
Okay.
they each get their own field.
Okay.
But
It's just too ridiculous. It's just all too ridiculous. Okay, we know all of this stuff is happening in this universe, and it all interacts, and there's no secret universe, and there's no secret place, and there's no secret sources, and there's no hidden stuff. I mean, well, hidden stuff is the wrong word to use. Obviously, some of it's beyond our perception. But there's absolutely no indication of a Sasquatch field or alien field or any of this bullshit. I mean, a gremlin field. I mean, it's just too fucking silly.
an up quark and an anti-up quark are in the same field. And an electron and an anti-electron are in the same field.
Also known as a positron.
Correct.
Okay.
Yeah, but it doesn't make any sense at all. And what is this positron doing? Where's any evidence this positron ever existed or ever is in an atom anywhere? Where are all the Where have all the positrons gone? We miss them so much. I mean, it's just so fucking stupid.
Every point in space has an existence value, essentially.
Oh, an existence value. It just gets worse and worse. I mean, you just say with virtual photons, and then they go entanglement, and they do all this wooey crap, and now they say existence. It has an existence substance number. This is solitons. This is it. So there's either God or the soliton.
And you can see that each of those points are wiggling. Every point is wiggling.
Sure.
That's sort of the...
But it's only wiggling in its field. So this is the electron field wiggling. And then there's another field that's the quark field wiggling. And every field is a different wiggly field. I mean, it's just too fucking silly.
quantum uncertainty going on here, right? If there's a large enough disturbance, a full disturbance in this field, we perceive that disturbance as a particle. Okay, so if there's a disturbance in the electron field, it might be an electron or a positron, depending on what the disturbance looks like.
Okay.
If there's a disturbance in the photon field, then what we're going to see is a photon.
Sure.
We're going to observe that as a photon, even though the
So we don't observe photons, we observe electricity. We observe a phenomenon created by the interaction of this energy, okay, with an atomic surface. So they've extrapolated into a whole bunch of theory about what this interaction actually is when you can dissect the fact that their understanding can't be the truth. Okay, photons aren't discrete little tiny things. The elements that make up the photon are discrete tiny things. They hit tiny little electrons. They hit protons. They hit atoms. They hit this little stuff. The bits that make the photon, but there's no possible way the photon could do it because the photon's polarization and wavelength is gigantic. It's thousands of atoms of polarization. How can you take thousands of atoms of polarization and have it affect one electron? It's not possible. It's spread over way too much distance, a photon, to possibly hit one electron.
photon isn't really there. There's no really particle there. It's just a disturbance in a field.
Is there an antiphoton?
Yes, but the antiphoton is just a photon.
Oh, isn't that interesting? Oh, God damn. The antiphoton is just a photon. I mean, so I have a doppelganger, but he's not a doppelganger. He's exactly me, and he's just me being over there instead of here. So somehow the photon has an antiphoton that's got to be somewhere else because it can't be where I am, right? Then it's just sitting over there, and it's saying, he's the doppelganger. We can't tell which one of us is the anti one. Oh, fuck. This is just so bad.
Photons are wild.
Yeah.
Okay.
It is its own antiphoton.
Oh, they're wild. They're just so wild and crazy guys, those little photons.
Particle. But yes, every particle has an antiparticle. It just might be itself.
Oh, fuck. Yeah, just fuck it. Fuck this. Fuck this. It just might be itself. Shit. All right, really, that's enough. Oh, crap. I've lived too long. Clearly. Planet of fucking moronic monsters. Can you people be dumber? Is it possible? Can you be more silly and frivolous and wacky and dumb and stupid and moronic? Fuck. This is a big physics channel, and they can be this stupid. Let's see. LOL, anti-photons. Yes, it is just so pathetic. Just so fucking pathetic. So there's 10 of you, so you're going to have to do something because I'm all done. So unless you provoke me with some sort of crap. Yeah, I'm just done. I'm done. This is just too ridiculous that nobody can interact, nobody can counter-argue, nobody can do a goddamn fucking thing. You're all so fucking crippled and stuck in the fucking Borg. You're all just like the movies where they have it's like the Terminator when you got terminated, you know, the metal guy, and he falls into the, the goop, and you're all just stuck in your goop. Yeah, I know. Wasn't that a point to stop? I mean, anti-photons can be itself. I mean, what the fuck? I mean, he said it, right? I mean, he's in a lab coat. He's saying something that fucking retarded. I mean, obviously that can't possibly be somebody's real theory. Nobody could have that as a real theory. Why do they even think? I mean, why can't they figure out that, well, look, it's one thing to make all these anti-particles for the material bits, but to do it to the force bits too. There's absolutely no reason to make antiparticles. I don't think Dirac insisted that his mathematics proves that there has to be anti-photons. So there's no absolute, they have a perfect out. They can say, no, it doesn't include radiation. So, electromagnetic radiation, it doesn't have antiparticles. They couldn't just have said that and just escaped. But instead, they're going to contrive a reason to say there are? Oh, fuck. Just what the fuck do you think the anti-photons are doing today, right? What are the anti-photons doing? If I'm going to... just like... What are they, like dark matter photons? I mean, you can't see them ever? It's just so ridiculous. I mean, he's making a serious video. He's saying this is serious physics. This is we're serious scientists. And it's just like, what the fuck? You just made up the wackiest story. I mean, you might as well just have, like, the Three Bears story, except that they're incestuous and you're going to explain how they're having oral sex. I mean, it's just such an insane story. How can you turn this perverse, bizarre, fucking bullshit into some description of a rational narrative of reality? Yeah, I guess dark matter is the antiparticle for dark matter is what? Darker matter? Oh, I mean, it's just, no, they can't do this. I mean, it has to be the opposite. It has to be very light matter. It's so light that we can't see. It's so bright. The brightness blinds us to it. And all we can see is the dark stuff because we're blind to the light stuff. I don't know. I'm just saying, they're just making, it's like somebody just saying improv. This is like science improv, right? And so somebody just says some words and gives you a condition and you just make up any wacky story you want. and try to be humorous. And so, yes, it is very humorous. The antiphoton could be itself. I mean, it's a pretty funny joke. Let's see, could be language. No, be causing most of the problem. I mean, sorry. I mean, this isn't a semantics problem. Antiparticle is not a semantics problem. I mean, they really are. I didn't realize, I was arguing with the guy about solitons and monads. Guess what? Okay, particle physics has taken those words and it now uses the word soliton and it uses the word monad to describe some kind of hadron or something. It actually is using those words. I mean, it really is an old dead religion that somehow I didn't know was still alive. The old, Leibnizian religion. Light speed proton, well, no, the protons are different than the photons, and anti-light speed protons, but it's like proton. I think he meant photon, but protons obviously don't do the light speed thing very often. Yeah, I don't think that's a common event. A lot of energy in a light speed proton. Probably could blow up a planet with that. I don't know. I mean, I might be exaggerating. I mean, they probably do reach very, very fast speeds. Jittering. Very fast. Stuff inside the atom is probably jittering around quite quickly. Is there any non-religious physics channel that exists? Yeah, well, no, there's absolutely no one talking rational physics. So if there was, I would be showing you all kinds of clips and I'll be like celebrating it and saying, "Oh God, wasn't that a great video? Oh man, that was super." No, but there isn't. Yeah, there's nobody talking anything rational except me. And all the dissidents are nut jobs, right? I mean, the Bill Gates guy makes some good points against the conventional theory, but his own theory is, what the fuck? Every single electron is connected to every single other particle in the universe? I mean, come on. Too silly. It really is. It's just so bad. I mean, it's just, I don't know. It's just quite depressing. Now, maybe it's just the only people that know about this channel are nuts. A few leftovers from my other channel, a bunch of people who are depressed or something. And some residue from the D. Hillsters and some other residue from some other place, and that's all there are. But clearly all the pop channels are talking such loop-de-doo shit. You're just saying, I guess that's not the problem. I mean, people want to hear the loop-de-doo silly story. Fuck. If an antiphoton is exactly the same as a photon, isn't that just a photon? Yes, I would imagine, but I guess somewhere it must have like anti written on its shoe. So the only difference is it has anti written on its shoe. Yeah, I don't want to hear anything. I want to understand. Yeah, that's what I want. I want to understand. I want a consistent story that is actually not full of contradictions and inaccuracies. I want a story that's solid and dependable, has a consistent plot, you know. You can't have an actor in the movie and he starts off 3 feet tall, and then in the middle he's 7 feet tall, and then the end of the movie he's 4 feet tall, and then, you know, this doesn't make any sense what they're doing here. No continuity, no consistency. Just like I said, there's nothing here. This is not, they're not telling the evolution story versus the wacky story. You know, they're just telling another wacky story. But you can see it. They're trying to quantize life now. You know, they're trying to ruin biology by shoving this wacky physics into it. It's just so depressing. The only truth we've got, they're shitting on. It's just amazingly bad. And these are intellectuals doing it. The literate people are talking all this shit. It's just fuck. How can people make physics videos like the one you showed today? Have they no respect? They have no integrity or honesty, that's for sure, because they'd have to say, look, we're just making this up. You know, if he'd be a little tiny bit honest, he'd say, okay, this is really a messy story I'm going to tell. You know, we just don't get it, and so we're just going to make up all this weird crap because we really don't understand a fucking thing about how it works. So we're just going to say, gremlins stole your left foot socks, okay? Obviously your left foot socks are missing. A gremlin must have stolen them, because we can't think any harder than that. You know, we can't figure out that there's a gap between the door of the dryer and the spinning part and things could fall in the gap. Or we're not going to find any rational explanation. We're just going to say, yeah, gremlins did it. And obviously the visible man is pushing stuff around in the galaxies. You know, the dark matter, his real name is Invisible Man. That's his real name. And yeah, he did it. I mean, this isn't even close to a good model. They haven't advanced their understanding of magnetism or electricity really in hundreds of years. And, you know, that should tell them your standard model doesn't explain magnetism and electricity or gravity. So why are you really bothering? It can't elucidate the most bold and obvious features of reality. It can't give you any information about how those things work. And yet you're selling it as an answer? Come on. Too silly. Well, you're going to have to look pretty hard. I can't find anything to interact with. I can't find anything to have a positive interaction with. There's absolutely nothing on the internet that has anything right. I mean, there's just nobody talking anything but shit. I mean, it's kind of bizarre. I mean, simple things, right? I mean, the very fact that in the banking crisis, the federal government did literally bail out the banks in a gigantic way. And it didn't bail out banks. It just bailed out rich people, okay, the owners of stocks. And they took $7 trillion out of the FDIC insurance policy, basically. They took on the liability of $7 trillion worth of liability to guarantee stocks that failed. So junk bonds that crashed and became valueless, that were owned by rich people, okay, they basically said to them, we're going to guarantee your losses. So whatever the original price was of the stock, we'll give you that money as long as you don't sell it. So as long as you don't sell it, it's worth what it says. If you sell it, then we're not going to play. Okay, so you have to hold it for a few years, and we guarantee it. That's what they did. They literally did that. That's an event that took place, and nobody in the public knows that happened. Okay, the Federal Reserve has $8 trillion in it. Okay, 20 years ago, it had $350 billion in it. It has $8 trillion in it. Okay, it's not a small change. It's a gigantic. It's $8 trillion of debt, okay, that's in the Federal Reserve. It's not the bank's money. It's not the economy's money. It's not the people's money. It's debt to rich people. $8 trillion of debt, IOUs, that have to be paid someday. Does anybody know it? No. Does anybody understand it? No. They all think it's the bank's money. They think the banks are just sitting on a big pile of assets and we're holding and hoarding all our money and we're not going to loan it to anybody. The banks are loaning money hand over fist. The banks are they're letting people put $10 down and buy a house. Just give us a $10 bill and we'll give you the deed to a house. That's what the banks are doing. They're lending so easily. They're lying and saying, oh, look at all the money they're hoarding. No, it's not their money. It's debt. It's federal fucking debt. And nobody knows. It's like nobody except me on this planet knows exactly what's happening on Earth. It's like if you want to know what's happening on Earth, you have to ask Gary because everybody else is a fucking imbecile. Okay. Anti-photon is not a part of the standard model. Well, he just said it. She asked the direct questions. Is there antiparticles? He said yes. Anti-photons. So you're contradicting him. So go argue on his comment section and tell him, you shouldn't have said that. There are no anti-photons. Why are you arguing with me? I played his fucking video, okay? He's very popular. Lots of people watch his video. Everybody's a fucking goddamn fan. They buy his moronic t-shirts. Why don't you argue with him, you motherfucking cunt? Why are you commenting on this board saying he's wrong? Why don't you say it on his board, you fucker? God, amazing. But they said it exists. Anti-photon would annihilate with photons. So what? Electrons are supposed to annihilate with anti-electrons. How come they haven't all annihilated? Oh, God, you people are just so full of shit. To create radiation, photons. I don't know. So photons annihilate and create photons. I mean, fuck you. Fuck you. Absolute shit. You have zero. I mean, you don't have evidence of it taking 4 times the fuel to go twice as fast, and you're telling me this fucking preposterous story. You can't even prove the shit that's 350 years old that you're saying. And here now you're saying some new fucking shit. Why don't you prove your old, stupid, moronic shit? Well, the debt limit they always raise. That doesn't matter. That's the real bond issuing, okay? Issuing bonds is okay-ish in the sense that that's not nearly as dangerous as putting $8 trillion in the Federal Reserve that if the banks do go bankrupt means we go bankrupt. because we can't give them the $8 trillion that's in the Federal Reserve. The banks use their checks to buy things. The checks are bounced checks. Nobody cashed them. That's why the $8 trillion is in the Federal Reserve. It's an IOU to the bank saying, yes, you wrote a bunch of bad checks. Here's the money for it, but you just can't use it. Okay? So if the banks go bankrupt, we have to give them the fucking money for the bad checks, you fucking idiot. So now all the banks are too big to fail. Not a single bank can fail under this circumstance. Not a single Federal Reserve member bank can possibly fail because of that $8 trillion fucking dollars. And obviously, if the Federal Reserve has guaranteed, $7 trillion and they have $100 billion in their insurance fund. So $100 billion in the insurance fund, $7 trillion worth of liabilities. How long do you think you're going to have any fucking FDIC insurance? I think the insurance will last about 14 milliseconds or 17 milliseconds, maybe. But that's it. There's no possibility there's any insurance because there's no fund to cover the liability. So where are you going to get the money from? You're going to beat up the old ladies and steal their Social Security checks? I mean, where's the government going to get the fucking goddamn money? Well, I'm just saying I played the fucker's video. He's saying what he believes anyway, okay? And he's pretending to be a scientist talking from some scientific perspective. So I think I've done my job to say, okay, here, let's play a scientist and hear what they have to say. All right, you're saying he doesn't say what the other assholes say. Well, whatever. How do I find the Protestants versus the Methodists versus the Catholics versus the whatever the other variety of Christianity, the born againers? They're all Christians, but clearly they have a completely different definition of how the fucking Jesus theory works. Jesus likes homosexuals. Oh, wait a minute. No, Jesus hates homosexuals. Oh, wait a minute. It's just too silly. Why should I have to argue all of these stupid, moronic, putridly unevidenced piles of shit stories? I have to prove there is no Jesus. Fuck. Yeah, come on, people. 16 of you now, right? Is that what it says? 16? You got nothing to say? 16 people, nothing to say? I mean, the beginning of this video was a pretty slam dunk, definition of reality. I mean, there's not a goddamn thing I said in the beginning of this video that's in any way wrong or even a tiny bit off of reality. It's just as clear a fucking picture as somebody can fucking goddamn draw. You should be saying, God damn, it's fucking amazing that we live on this goddamn planet. These people are talking this shit about what gravity is when it's obvious what gravity is. 9.8 meters per second. Why the fuck are you saying per second when you think distance has something to do with it? It seems to me the whole thing is screaming it's about time. It's not about distance. Well, the simple truth is, you can talk about what they believe, but they obviously don't believe it very well because they don't have enough confidence to take my $3,000 and let me show how their physics is crap. They're obviously not confident enough they can make a rational defense of their crap when a real lawyer gets into the ring and argues how full of shit their fables are. I mean, they have no evidence on the evidence table. They just have stories. Well, how much of it's just a lie? I mean, again, the two-slit fake crap. Oh, well, we put detectors on, and we detected the photons, and we detected they weren't there, and we detected... they didn't do any of this shit. I mean, it's all these lies about what experiments they did, what they proved. They're not just oversights. They're fucking lies. The most proven theory in the history of mankind. Well, if you consider actual rubbish as proof, as long as you think garbage is food, then it's the most food ever produced. I mean, the perversion is the distance from the scientific method, right? They have no respect for the scientific method. They just couldn't care less. It's not the agenda. Evidence, smevidence. All right, they are responsible to provide evidence of their photons and antiphotons. The burden is on them. They can't. Well, they can't make their story consistent is the point. The young double-slit analysis doesn't work, plainly. It will not describe the double-slit pattern. It will only describe the single-slit pattern. And if he draws the single slit as a wave, a water wave, it won't have any pattern at all. So it doesn't work at all. It's a fable that this has something to do with understanding the truth. It doesn't get right answers. It doesn't fit the actual events that happen with photons. Photons are distinctly different than water waves and sound. Distinctly, completely different. And again, it can be proven by just everybody's personal experience. If you're as old as me, okay, in the old days of radio, okay, where it wasn't digital and the signals weren't all or nothing, you could drive and be in a place where the radio would switch stations. You'd be getting Chicago and then you'll get some Canadian station from the same number. You could actually do this. And the waves weren't banging into each other. They were coming from opposite directions. Okay, so they couldn't be entangled and superimposed and all that mush. They were causing an interference pattern with absolutely no interaction with each other, which kind of demonstrates that theory of interaction is bullshit. It isn't destructive interference because they never interfere. Fuck. So I'm just saying these things can be argued. It's just nobody's made the fucking arguments. Nobody has sat down and said, this current theory sucks. Let's figure out a better one. And they end up with the few people who do it end up being like the stupid fucking goddamn Getty guy. They end up with some wacky, well, what if I tie a string to every single particle in the universe? Yeah, well, then I can make everything interact. Fuck. So, I don't know what to say. It's just that I don't know why these truths are not that... I mean, I had to spend 10 years pretty much dedicated to this subject. So, I did have to do quite a bit of work to kind of put all the flaws together and figure out why all the reasoning wasn't fitting. But I'm just saying it wasn't a miraculous thing, okay, and it should have long been done by some scientist, should have said, this doesn't... Well, Einstein did say it. Einstein said, we're talking shit. Einstein basically said to physics, we are talking shit, okay? Let's find a better pile to dig in because it was just shit after shit after shit here. We're digging in a manure pile. Let's go somewhere else and look somewhere else for the truth. And he just didn't, he was so close, I would argue in a way, because he started getting the force bit thing, making the photon, but he didn't really understand electrons and protons, and that was the big miss. And clearly the bent space thing was just, he had to keep defending that, and that was just totally irrational crap. All right. Maybe dialect. We've already done this. I've played a couple of his retarded videos. Was right when he said different physicists have their own interpretation of modern physics. Well, obviously they do, but obviously they belong to clans or groups. I mean, I just pointed out it's like Methodist and Protestant and blah, 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 blah. You know, there's no individual independent thinkers here at all. So please point me to that physicist that actually figures out something and how it works and then proposes it as an idea. Show me that. And show me an idea that's not more irrational. So show me a paper written by somebody that isn't crazier than the current crazy. I think they need to produce one answer because this causes confusion. Well, I think they're allowed to fudge a little. So I don't think they have to say it's green. They can say it's, ultramarine or something. I don't think they have to get explicitly right answers, but they have to concede where the stuff doesn't make any sense and they're a direct contradiction. So they admit that bent space doesn't fit with quantum mechanics, but they're unwilling to say one of them's wrong and it's got to go, or both of them are wrong and they both got to go. That's the part they're unwilling to do. So they kind of know that they're really never going to find any way to make bent space into a mechanical field theory. It's just not going to work because there's no energy, there's no cause. They can't really, they have an effect and they have no cause. That's never going to fit into any kind of mechanical model. You have to have a cause. So until they figure out that the cause exists in the field, that is, the energy is already in the universe, okay, and that's where it's coming from, until they can figure out that part, that it's a push universe, right? I shouldn't even have to do this. Should I have to do this logic and say, oh, I have to explain to physicists that it's a push universe? That pull is a silly idea? There's no elemental pull anywhere ever? I mean, the fact that they haven't even done that much, they haven't even gotten elemental enough, like go all the way, get themselves in a trance, go all the way to the lowest level and figure out, push is so easy. And pull, fuck that. How the hell do I do that? Push is easy. Bang into something is so fucking easy. How can you not? I mean, that's just, you don't have to have any brains to do that. But pull? No. No chance. So the fact that they can't even unify under that word, push universe. The fact that they can't say what I've said over and over again, the small universe is the only universe. Everything that happens there a long time before it happens here, okay? My brain is moving so fucking slow. These sentences, these words, this is so fucking slow. The real universe had billions of interactions, trillions, gazillions of interactions for me just to say the word poo. There, poo. That's trillions of interactions to make that word. Trillions of things happening in the little universe to make one fucking little stupid sound. So get real. That's the real universe. The real universe is the little universe. They keep looking out there. They keep building their telescopes to look at the little gas blobs and the little things and their stupid rays and their stupid black hole crap and all that mush. They waste so much time looking at the pictures, of the bullshit. The colorized pictures, by the way. Fuck. So yeah, they should be able to say push and small. These should be two words that are really big in physics. Smalliverse, pushiverse. Yeah, you can say there has to be. I'm just saying there is none. Okay, a debate channel. What good is a debate channel with two guys who know no physics at all, right? So that would be useless. So, but yes, you need a physics channel willing to discuss physics, and there is none. They're willing to debunk crazy people. So they will go out on the internet and find some crazy, obscure lunatic who's a flat earther and debunk them because they know he's psychotic and they can pick on psychotics. But anybody with any kind of physics knowledge that's actually capable of challenging them, they are pathetic cowards, and they won't go anywhere near that. But I have literally 70, 80 channels I have emailed offering financial compensation, sometimes up to $4,000, and I can't get them to do it. So the Thunderfoots, the Veritasiums, and the blah blah blah, and all that crap. I've shown the emails, you know. I'm offering them money. I'm even saying to them, please tell me how much more you want. How much more do I have to give you? And they won't answer the question. I'm basically saying, I'll write you any check you want. So tell me the fucking goddamn number. Say $10,000 and I will try to raise it. But say the fucking words. All right? Tell me that you're so much of a coward that I have to pay you a preposterous amount of money to counter my argument. All I'm going to do is make an argument. MGT. I'm going to make an argument, explain why the argument is valid. And all you have to do is explain how your physics is more powerful. And all you have to do is put your little hands up and shoot your little lightning at me and prove that your good force is much powerful than my evil force, blah, blah, blah. That's all you have to do. You don't even have to take out your lifesaver. Just use your little electricity thing and defeat me. But these cowards won't do it. These fucking Psyman fucking boy won't do it. Girly boy. I think it would be important for you to debate one of these types of scientists who have a lot of views on their channel so people can see what makes sense. Free energy versus MGT, MV, etc. Yes, of course. I'm going to win the argument. But I need to have it to win it, right? So there's no doubt I am the Mike Tyson on these subjects, okay? I'm going to beat the motherfucking shit out of these assholes. And all I have to do is stay off the drugs and not rape any women, right? And I'm going to be the world champion. Yeah. I mean, I really can't lose the argument. I mean, I've explained how the argument is so fucking obvious. I can't possibly lose. And I got it on more than one subject, right? I mean, I got it nailed on, you know, my simulation. Then I got it nailed on the double slit experiment. I got it nailed. All right. And then I got this MV squared shit nailed. I mean, it's just nailed. It's dead. It's crap. It's shit. All right. And I've shown you all the ways it has to be shit. You know, and these morons are saying, no, it's 1.4 theory. You know, which the physicists don't actually have. They think Professor Lewin actually thinks springs don't work. Guns do. Guns conserve momentum, but springs don't. I mean, it's all so fucking stupid. This needs to be set up as soon as possible. I'm just saying, I've been trying for 10 fucking years, shithead. So I'm just saying, yes, if you wish to try to help, thank you, okay? But I raised, you know, I actually did solicit people to contribute. Let's create a prize. You know, that's why I was able to, you know, feel okay about offering big piles of money, because I figured I could probably get my viewers to pay half of it anyway. And you can't bribe them. You can't. There's no bribe I can create. They will not be bribed into it. Yeah, we had Baldy Katz on. His ego got to him, and he thought he was the man, and he agreed to the debate, and then he weaseled the fuck out. The trolls gave him an excuse, because they said a bunch of lies about who I was and what I defended, and he used that as an excuse that I'm just too disreputable a person, and so I don't have to have a debate with you. But he tried to get AB Science to take his place, and that weasel bailed. I asked him directly, how much do I have to pay you? And they won't answer the question. What, you mean there's no price? $1 million? You can't even utter the words? Oh, no, it'd take $1 million, literally, yes. It's too risky for me. I'd have to have $1 million to take that chance that I might lose the argument to you. I need $1 million worth of life insurance money, because I'll be ruined if you win. It's just hilarious. They need insurance against me winning. Oh. Against their millions of scientists and trillions of dollars they've spent on crap. And they're afraid I am going to defeat it all. They're such girly, cowardly Goliaths, right? They're this giant Goliath, and they're just such pussies. I have to be able to run very, very fast just to catch up with the Goliath running away. I know, that's what I have to become, right? See, I have integrity. I just can't do it. I've thought of it. I've said, well, maybe if I just maybe if I say something supportive to the flat earth community, and then I'll be a flat earther, and then they'll attack me. But I have to ruin my own credibility to do that. And I just can't do it. I can't be a UFOer. I can't be a flat earther. I just can't pretend, to be an imbecile. A psychotic imbecile. So we'll see. Somebody can come up with an argument to the first half hour of this video, right? I mean, the first half hour of this video, slam dunk, bang, bang, bang. And let's see, somebody come up with any kind of argument at all, anything, pointing out how I said anything out of line. Anything that should be repugnant to a scientist. It is kind of funny because I was a pretty good pretender in my youth. I worked in restaurants, just part of the time, part of my employment, and having a personality was kind of good for tips. So I was a bartender and a waiter and all those kind of things, and I ended up having a personality. I could be anything. I could be a little bit French. I could be this. I could be that. And I was very good at pretending. It's just kind of funny. And but now I can't. I have just zero patience. Sometimes it's just a little bit of mockery. I can acquire some other personality for a moment or two, but it's really hard to fake it. I mean, I just find it, it's revolting spidey sense. Is there really any point in conversing with the brozos? Well, I'm just saying it's the only game in town, so in that sense, there is a sense to it. They're making some kind of form of an argument. Yes, it's not direct, it's not on the subject, but they're making some counter claim, that you don't have to conserve momentum and that springs don't work but guns do, and they're making all these arguments, and so you do have to kind of counter them and say, well, that's just plain shit. I mean, obviously they don't have they haven't said anything for a few days, so I mean they're out of the game until they fake their next experiment. But till then, there'll be no news. But yeah, they won't deal with what they're really saying. I mean, they're saying they're defending physics, but they're really not defending conventional physics in any way. They're defending their own theories. Their 1.4 theory that no one's heard of. But like I said, I mean, I can't make it any easier, right? I mean, I put the target right in the beginning of this video. First half hour of this video is just a perfect target. It's just sitting there, perfectly drawn, perfect hard lines. Hit the target somewhere. Somewhere point out where the mistake is. You have to show me the mistake. Okay, the error in reasoning. All right? And that's their obligation, but they will not show that error in reasoning. I don't know. Reddit is I want a video. I want to argue with somebody in person. I don't want to argue in text. That's for certain. So, if there's going to be a conversation, I want it to be a conversation. I'm not going to write a thesis. Forget it. So they have to be able to watch a 10-minute video. I'll give them a 10-minute video. I'll say what I said in the first half of this video, as quickly as possible. And then we can expect their counter argument. I just want their counter argument. I don't even care if it's a live interaction. I just want the counter argument. Provide me the counter argument in some form. Text, I don't care what it's in. But I'm just saying, I've already done the forum thing. Okay, the forum thing is just F equals MA. They just keep saying F equals MA over and over again. They don't say anything. I don't know. I mean, I just don't. Okay, you think Reddit's somehow more popular than YouTube, and there's more eyeballs, and there's more the right kind of people or something. I don't think so. Reddit seems like a troll paradise, so I don't really get your point, but whatever. Fine, whatever. It's not my inclination. I'm findable as it is. I mean, if you can't find thousands of YouTube videos, I don't know how you're going to find a Reddit post. Well, I'm not afraid of trolls, but I'm just saying that obviously they ban the person who's right, and they, so they can celebrate and dance on your grave. So I'm just saying that all of the forums are controlled by them. Okay, the Catholics control all the forums. You can't speak evolution on the forums, so to speak. You can't argue their physics. All you can do is talk about how glorious it is. You can't tell them. You can't tell them their God's a bucket of shit. No, you have to praise their God. I mean, look, YouTube, in my opinion, is the most populist media source. I mean, it's just so obvious, so complete. This is where the physics lectures are. I mean, is there any better physics content anywhere on the internet except for on YouTube, essentially, or on the university websites themselves? But most of those are just YouTube videos published on the website. So I'm just saying this is where the stuff is. I don't know where you think better physics conversation is taking place, but I can't find any physics conversation anywhere on the internet. Again, unless you're just talking about how many hairs are on a photon's butt. You know, they'll talk about that all day long. How hairy do you think the black hole is? Oh, you think it's got like really big hair or little curly hairs? Or do you think it's blonde or is it got black hair? Or what color hair do you think black holes have? Oh, fuck. Don't even say the word Facebook to me, fucker. Why the fuck that thing ever got popular? Fuck. Monstrosity. Not even an anti-Gary would go on Facebook. So if I did have a doppelganger that was my exact opposite, he still wouldn't be a Facebooker. I mean, the very fact that you need some commercial company to organize a nothing website. I mean, absolutely nothing. Here's a picture of me, sticking my finger in my nose. I mean, it's, what the fuck? I mean, somebody couldn't create a public domain Facebook? Ugh, it revolts me to my core. That you people are just saying, please, no, I can't possibly go to Facebook if there's no advertisements. I mean, what the fuck? I won't know what I'm doing without the advertisements. It just rubs in my nose, the fact that assholes control the internet. That the internet was controlled by CERN, right? The very people doing the Hadron Collider, right? CERN is right. The Hadron Collider, CERN, they're right next to each other. Same thing. And CERN owned the internet, and they gave it away to the capitalists. They said, oh, we have to make some money off of this, so we have to start renting things instead of buying things, and we have to start, And it's just disgusting. They just gave the internet away to the capitalist cunts. And it's just, so disgusting. They could have made it a beautiful library. And instead, they made it a whorehouse. That's a good quote, by the way, right? So when I'm dead and you go Google Gary on the internet and you get his quotes, that's going to be one of my quotes. Right? They turn the internet from a beautiful library into a whorehouse. I'm full of them, by the way, these quotes. It's like every day there's something quotable. Every fucking day. So when you go to get the quotes from, famous Gary quotes, there's not going to be like 13. There's going to be 20 years of a quote a day. Yeah, that's a lot of quotes. Hundreds and hundreds, thousands and thousands of brilliant quotes. So that's the future you have to look forward to. Someday. Tomorrow. There's always tomorrow. All right, let's see. You really have good metaphors and quotes. Yes, it just happens to have... It just happened to fall out of my brain. All right, so I guess we'll call it a day and such. So, thank you for the participation. It's still a little too thin, but I know you're trying the best you can and all of that stuff. So, You're doing your best, but the 15 of you just can't quite do enough. But it's okay. You're trying. Likewise, I'm doing my best, and it's not working out very well either. But, you know.